Hi, welcome. I'm Brad Green. I'm the manager of accessibility engineering at Google, and
I'm Erin Rosenthal, the product manager for accessibility.
fantastic. So we're going to talk a little bit about what accessibility means in products and how we can use features that are built into the platforms that Google offers. Erin, can you go to the next slide? Okay. So just a couple of questions. How many of you have some experience with accessibility technology already? Okay, a little more than half. That's fantastic. How many of you are actually responsible for building accessibility into your products? A couple of us. Okay, keep your hands up. How many of you know the current gaps in your products and know how to fix them? Okay, fair number. Okay, so but that's what we're here to talk about. We're going to, first of all, talk a little bit about what users expect or are looking for in accessible products. And I'll just make a point that we're going to go into some particular use cases, but the range of accessibility is wide. There are a lot of different use cases, ways that we like to make our applications accessible. What we're going to talk about forms a framework for many different modes of accessibility that users can take advantage of in your apps. We're going to talk about how you build accessibility specifically in our products, Chrome and Android. And then we're going to show you what tools we have to both build and test these applications. We're going to follow with some cool demos. We're going to show you what we think are inspirational applications that show off some of the best features in accessibility.
So you're probably asking yourself, granted, most of you seem to know a lot about accessibility already, but a lot of people ask, why should I care? Why should I make my product accessible? Well, there's a number of reasons. Number one is actually it makes financial sense for your company. The government and education tend to have requirements for accessibility in the products that they purchase, and they're very large contracts, very large groups that you can sell your products into. So it's really important to make sure that your products are accessible so that you can compete in that marketplace and get them as large paying customers, right? The main reason that government and education want products to be accessible are so that students can continue to learn and learn alongside sighted students and hearing students in school, and so that as people grow and move into the workplace, that they can continue to work alongside their peers in companies like ours, right? Also, I know for me, it always helps me when I work on something that enables people to do something they weren't able to do before. That feels great. And I like working on accessibility because of that it's a good feel-good thing, right? So you can see that people weren't able to do this and now they can. Wonderful. Also, there's a lot of additional technology benefit to making your products accessible. A lot of the underlying technologies that you put into your products will benefit you in other ways. So, like for example, with Android, when we were making it accessible, we added a text-to-speech engine. Well, later, that came in handy as a way to do driving directions in the Maps application. We already had the text engine there, so it could just rely on it there.
That's right, Erin. Matter of fact, there's a lot of other places where accessibility is kind of like a moon mission. The technologies we develop that are for helping people access the platform are usable to everybody. Matter of fact, they help all of your users. For example, in keyboard access, we as developers, we rely heavily on keyboard shortcuts. Adding keyboard access to your application is maybe the #1 thing for web apps that you can do to make it more accessible. Not just for folks who might not be able to use a mouse, but for everybody. Like, I want a hotkey for almost every one of the use cases that I have in an application. There are some technologies like text-to-speech and speech recognition that were once thought of as exotic interface elements are now becoming commonplace. You notice on Android, I can add a speech recognition element to take input. Also on many devices, we have the ability to give vibrational feedback, what we call haptics. And video game developers found out if they made the controller vibrate when different events happen in the UI, it becomes a much more real experience. The same is true for my applications. When I can give some input to the user that's not doesn't need to be overt. I can make the device vibrate and make it seem like a real part of my world. When I caption video streams, it not only opens up the video to folks who can't hear, it allows me to do really interesting things. Like you could run the captions through a service like Google Translate, and all of a sudden, all of the people who aren't native speakers can now access the video content. Customizable UIs, as one example, in Gmail, I can set my theme. and be able to set theme elements, backgrounds, contrast, colors might be kind of a nice thing. Personalization, adding bling to my environment, might be actually also required for some folks who need different contrast, different colors, different magnification in my application. Testability, finally, turns out that if I'm building an automated test, it has a lot of the same needs that, say, a blind user needs. Like, my automated test can't use the mouse and usually can't read the screen, and so these accessibility features form a very stable API for me to build automated tests against. Let's go next.
So let's talk a little bit about the users, people who use accessible technology. It's really important for you to understand them and how they interact with your products, just like all your other users, right? So main thing to keep in mind are the input and output technologies that they use, and making sure that you have multiple redundant ways of interacting with your applications. Basically, not relying on a mouse, not relying on rollovers to be able to get to your content. So main ones to keep in mind are for input using keyboard and voice and touch, and then some special purpose displays like this Braille display that we have pictured here where you can do chorded input. And then also for feedback, feedback's really vital so that your user knows where they are on the screen and what they're interacting with at all points in time, right? So you should make sure to have, again, redundant feedback as well. So not only have speech, but other audio cues for when tasks complete or other notifications are happening, and also vibration feedback so that you get that sense of reality when you're using the product. Plus, keep in mind other things like the Braille display that we have here as another input or output device in this case.
Okay, so we've got a list of a couple things, some sort of rules of thumb for making accessible applications, how to think about what sort of features I need to pay attention to as a developer. First of all, I kind of mentioned this. Make sure that all of my use cases can actually be completed without using a pointing device. How do I do this? Well, I unplug my mouse and I try and use the application. Usually, this means that I'll have implemented keyboard shortcuts, that I make sure that if it's a web app, that the tab order makes sense, and that I can actually focus on every element on the screen. I also want to make sure that I am managing focus well inside my application. For example, if I'm using HTML to simulate a modal dialog, I want to make sure that I'm actually trapping events so that if the user's trying to tab through the elements, that they can't actually reach the elements that are behind my floating dialog box. If you want more information on this, we've got a session tomorrow which does a deep dive on building accessible HTML applications. Depending on whether I'm on Android or on the web, there are several declarative ways that I can tell assistive technologies how to interact with my application. In the markup in the XML for my Android application, or in the HTML for my web-based application. We'll go into a little bit of this, and we have talks here at I/O that go much more into depth on both of these. And then lastly, for me as a developer, if I'm building custom controls, things that aren't part of the standard widget set, either on Android, or if I'm putting a bunch of divs together to look like some kind of crazy new control in HTML, I'm going to have to do a little bit of extra work to add accessibility support there. And finally, I should need to test it. It's certainly disappointing if I put some work into making my application to be accessible, and then find out that maybe my login screen is not accessible. So I want to make sure that I test all the flows with the assistive technologies that I'm targeting.
So what we're really talking about here are creating these empowering products that enable independence. These are products that work out of the box, are easy to use, that someone can set up by themselves, and that are really easy to learn and provide that good feedback so that they can get familiar with the environment. This is such a liberating feeling, being able to do this all on your own, and it's really the right thing to do. Also, as Brad said, keep in mind to test your entire product and not just think of like the main part of your interface, but that from login through documentation and even your help center, that all of that is also accessible.
Okay, I want to take a little bit of a closer look at building web applications and what makes those accessible. So if we get in the Wayback Machine and think back to the 90s, when the web was simple, how many of you used Mosaic? Oh, wow. A bunch of us are old. Okay, good. accessibility back then was a simple problem. Usually, web pages looked like this. It was a bunch of text and links and maybe some images. And accessibility meant adding alt tags to images. Matter of fact, a lot of us used alt tags when my modem was too slow. I'd turn images off and I'd just read what the alt tag said. But the world has changed. Now, even our most simple applications like Google Search have become very rich and interactive, so that as I'm typing, Google Search updates my complete set of search results. So we need to think differently about how we're providing accessibility to these interactive, dynamically updating applications. And they've gotten even more complex and interesting with apps like Google Gmail and Google Calendar, like you name it. There's so many apps out there who have even richer interfaces. So, as I mentioned, one of the first things we want to do is make sure that I can access all of the workflows in my application via the keyboard. Gmail, for example, has a great set of keyboard shortcuts that give me access to some of the most common actions. Some of the other actions I'll need to be able to complete via other keyboard focusing by tabbing through the application and activating through the keyboard. I also talked a little bit about that there is specific markup I can add to my HTML page. In the web, there's a standard called ARIA. And ARIA gives me the ability to tell assistive technologies like screen readers and Braille devices how to interact with my UI. So in my toolbar example I have here, I've marked it up so that my images, which are what someone who's using the mouse would interact with, so that if I'm using a screen reader, I can know that that B up there is not just an image, but it should be interacted with as a button, so that a screen reader can announce that this is a button. Matter of fact, it has a label that's specified by my alt text there, that this will turn the text that I have selected bold. All right, so specifically, what is Google doing to help? I have a couple announcements today. I'm very excited to talk about 3 things. First, in Chrome, yesterday we just blogged that we're adding support for some of the major screen readers on Windows with JAWS and NVDA, on Mac with VoiceOver, and several others. On Chrome OS, you can't actually install other software except via extensions. And so we're making available a screen reader we call Chromevox. And we're making it available to you developers early through a download. So you can not only use it via Chrome OS, but you can actually install it in any version of Chrome and use it on Windows or Mac or Linux so that you can see what it's like to interact with your application using a screen reader. We'll take a look at this a little bit closer later with a demo. And then lastly, we know a lot of you photon-dependent users, folks who use the screen, like to see what things look like. So we've built an application called Chrome Shades. And what Chrome Shades does is it shows you what your application looks like to a screen reader. And it allows you to explore your application visually, but in the sort of linear fashion that a screen reader would interact with your application. We'll take a little look at that, and if you want a deeper dive, please come see us in the developer sandbox. Okay, so what does Chromevox do for me? For those of you who aren't familiar with the screen reader, it does a lot of the same things. Provides spoken feedback as I navigate through the application. It uses ARIA, which we just looked at, and other accessibility standards. And it helps me work with dynamic web applications that we're now seeing by giving me dynamic updates. It tells me when things change on the web page. So there are some cases where I want information spoken to me, and there are some cases where I don't want kind of the intrusive voice to come up, but I want maybe just an audio indicator. We call these things ear cons, little sounds that tell me when something has happened. For example, when a web page is finished loading and is ready for me to interact with it, we'll play a sound rather than announcing it with speech. One thing we're doing differently with Chromevox than we're doing other places. So we looked at ARIA. ARIA is a declarative way for me to specify how screen readers can interact with my app. Now, declarative is great. It's very easy. It's not prone to bugs, but it doesn't always work for all cases in a dynamic application. So we're giving you, the developer, a imperative way to tell it what to do through something we call Vox scripts. Vox scripts are just JavaScript written against a very simple API that lets you tell the screen reader what to do. And let's take a look at what it lets us do. There's a couple simple things. Number one, I can position the screen reader. I can tell it, start reading from this point. So for example, if I've got a toolbar that goes across the top that isn't something that I always want to interact with, maybe I'll start the user reading below the toolbar. I can position it by passing it the DOM node that I want it to start speaking from. I can also just have it speak some text by calling the speak command. And then lastly, we can have it play one of our earcon audio indicators. So a couple fun things to play with. So VoxScript bridges some of the gaps we have in our declarative aria and gives us ways to have more direct control. All right, so I'm going to invite Charles Chen up to the stage, and he's going to give us a demo of Chromevox right now. We'll get to see what it looks like.
Switching over.
Oh, okay.
Okay, and actually, while Charles is setting that up, does anyone have a question I can answer right now? Please come to the mic.
Chromevox looks very interesting. I was wondering if the GWT team has actually taken a look at this so that we may be able to work with widgets that we build in GWT.
That's a great question. Now, so the UI that you saw we have is, or the API is via JavaScript. And you can, of course, call any of those from JavaScript. But it's an interesting question, like what could we automatically enable from GWT? But come talk to us later. Let's discuss further. Okay, one more question maybe, and then we'll go to Charles.
Well, I'm from the GWT team.
Oh, hey, great.
And we don't have any thing in progress on that, but we'd love to talk to you about it.
Fantastic. Okay, good. Hey, maybe the three of us could get together. All right, let's switch to Charles, who's going to give us a demo of Chromevox.
Thank you, Brad. So if we can switch, okay, cool, we've switched. So Erin earlier was talking about how important it is to have out-of-the-box accessibility. And we have this with Chromevox on Chrome OS. So right now you see the login screen. If I press Control-Alt-Z, I can enable Chromevox.
Accessibility turned off.
It said turned off because it was on before, so let me go re-enable it right now.
Accessibility turned on.
Okay, so now accessibility is turned on. I can start using it. I'm going to log into my account, and then I'm going to show you just how easy it is to do a Google search.
Asterisk.
And notice it's saying asterisk, it's not blurring out my password, so.
Signing in.
Tell me signing in. Okay.
New tab.
Now you heard it make that noise, and it said new tab. So that noise is an earcon. It's telling me that the page is loaded, it's ready for me to interact with it. And it told me the title. In this case, it's new tab. So let me just do a search. So now this is Chrome OS. It's just like Chrome, the browser. So if you go into the URL bar, you can type a query, and it will just do a search right there. So let me do that. I'm going to press Control-L to jump right into the URL bar, and I'm just going to type. Now let's see what happens.
Location. Text box. Web page. Unselected. www.weather. Google search.
Okay, so it did a Google search for weather. Now this is Google Instant Search. So Instant Search by default draws a little arrow next to the current result that the user is looking at. And the user can use the arrow keys up and down to move through the search results. So we looked at that and we said, this is a wonderful keyboard-driven interface like Brad was talking about, having good keyboard accessibility. And so can we take advantage of that and leverage it and use some VoxScript to make it work even better and make it just speak what the user is currently interested in? So rather than having something complex where the user has to look at the title, look at a snippet, and then go back to the title to activate something, could we make it as simple as just pressing down an arrow, hearing it, and then just pressing enter to go to the page? So here's the results. I'm going to press down arrow and up arrow a couple times to show how it works.
Weather current conditions and forecasts for the San Francisco Bay. Mate. National and local weather forecast. Hurricane. Radar and report Mate. San Francisco weather forecast and conditions Mate. National and local weather current conditions and forecast. Weather for San Francisco. CA 62 degrees Fahrenheit vertical bar degrees Celsius due wet through fry sunny partly cloud.
Okay. And also very important right there, I press control to make it stop speaking. So, speech is silver, silence is golden, right? So as you can see, it's very easy to do a Google search, very easy to get your results. You'll also notice that the text got larger. That's because we applied a CSS style sheet. So for low vision users, you get not just the audio, but you also get the visual of it getting larger. And so with that, that's a really good intro to how we can do something that's complex with Google search. But let's look at something that's even more complex. Let's look at Gmail, right? So Gmail tries to replicate a desktop email client experience in the browser on the web with just HTML and JavaScript. So how can we make that accessible? Can we make that fast? Can we make that efficient, right? And the answer is yes. Yes, we can. So again, we're going to see how we take advantage of existing keyboard shortcuts and we make things just work. So let me load up my Gmail here.
WWGMAIL mail COM degrees Celsius.
Okay, so it's loading. Okay.
Mail inbox 309 CLCISL 33T at mail.com.
So as you can see, it told me the title and it told me how many messages I had. And so with Gmail, if you have keyboard shortcuts, you can just use the J and K keys to move through the different threads of emails. You can press Enter to open an email. And after you've opened an email thread, you can press N
Not
and P
selected.
to go through the messages inside the thread. So I'm going to go ahead and do that right now.
Unread. Thomas left square bracket Perks right square bracket Windows registry installation unread. Group left square bracket unread. File left square bracket unread. Has in blue 1.
Okay, so I'm going to go ahead and open this thread. I'm going to press Enter.
Not selected.
Okay, so now it's told me nothing is selected. I can go ahead and read through the messages with N and P.
Clear.image has in blue 1 to Android show details Monday, May 9th, 2011 at 10:52 p.m. I am developing an Android application for decryption of messages. I need some hash algorithm to generate. Clear.image Nikali Lenkov to Android Develo. Show details Monday, May 9th. Clear.image to Android show details Monday, May 9th, 2011 at 11:59 p.m. developer.android.com/reference/java/security/spec/mgf1.
Okay, so that, see now that was actually a very interesting URL. So I wanted to explore that more. And as Brian Erin mentioned earlier, with VoxScript, you can sync the screen reader to your current position. So now I'm on this message. Let's say I wanted to read that in more detail because that was just way too fast, right? So I can use the standard Chromevox commands to read through. So on Chrome OS, this is search and shift. And if you're running this as just an extension of your Chrome browser, then it's Control and Alt. So I'm going to read through this message.
Clear.image to Android. Table. Show details 11:50. Developer.android.com. Developer.android.sentence. Word. Developer. Reference/java/security/spec/mgf1 parameter spec.lol. SHA-256. SHA-256.
So as you can see, I can now navigate through it in a very fine-grained way and go through the message a word at a time, sentence at a time, at any level I would like. And so with that, I would like to hand it back to Brad.
Great. Erin?
I think that's actually
Not
me.
selected.
Yeah. So can
All right.
we switch back?
Yeah, switching
Thanks,
back.
Charles. That's awesome.
Yeah, thank you so
Were there
much, Charles.
questions, or should I? Okay.
So as you can see, with Chromevox, you're able to make like a desktop-like experience through your web application on Chrome OS, right? Chromevox and the Vox scripts give you this unprecedented level of control to make sure that you have this tight integration that you want with the screen reader so that you can provide this seamless user experience that your users have grown to expect in their desktop applications. There's also one more technology that Brad had mentioned that we wanted to show you a quick screenshot of, and that's Chrome Shades. So this is an extension available on our website, and it allows you to visualize what your website or application looks like to someone using a screen reader, as Brad says, for people who are photon dependent. So what it does is flatten your page and show it in the link order that the person who would be navigating with a screen reader, how they would come to it and how they would end up navigating it. So in this case, you see that the buttons that are across the top of the page end up being linearized at the beginning of the Chrome Shades version of the page, and that any button that's unlabeled in the interface is showing up as these green rounded rects. So clearly, we have some work to do here. It's a good thing we have this tool. So let's talk a little bit about accessibility in Android. Mobile platforms are fantastic platforms for accessibility. There's so many sensors built in that there's this inherent accessibility that's already there. These devices are designed for use when being distracted, when your eyes are elsewhere. So that helps people who need accessible interfaces as well. Plus, Android in particular is an open and customizable platform, right? So you can choose the device that works for you. You can get one with a keyboard if you want it. Plus, also, today when we were in the keynote, we announced the Android developer platform, right? So you can make third-party extensions. So with that, you can make something that really is specific to the disabled users in your community. So as we said, there's all these sensors built in. So think of them as all these eyes and ears that you can use to make location-aware, context-aware, and extremely powerful applications. The more aware your application is, the less that your users need to interact with it. While that might sound like something you don't want them to interact. You don't want them to have to get stuck inputting all this tedious details and all this data, right? If you can tell them the location for them instead of them having to figure out, like right now, do you know where you are? If you had to put in your location, no, you'd have a hard time, right? So you really would prefer your phone to be able to set that for you, right? So we've written a couple applications that demonstrate this technology. Both of them, I think, we're demoing over in our sandbox, by the way, if you want to check them out yourself. The first one is an app called Walkie Talkie. This is an interface to the Maps app that gives you the ability to set a start and end point, and then it'll give you walking directions for the route that you're on. Then, as you're walking along your route, it'll read off whatever intersection you're at. I know for me this would be incredibly useful if I'm just kind of walking in an unfamiliar area. I can only imagine how valuable it would be if I'm blind and would have a difficult time seeing exactly where I am. So this application helps build that confidence in your environment and knowing where you are and that you're on the right direction. Also, there's this application called Intersection Explorer. If you went to the Android talk earlier, you saw a demo of it. And as Raman explained, he wrote this after getting dropped off on the wrong corner one day on the way home. This app helps you to understand what intersections or what streets are nearby. So like if you're traveling and want to get to know an area before you get there and know what the general streets are, you can open up this app, set yourself at an intersection, and then drag your finger in a circle around the intersection that you're at. It will then vibrate subtly when you get to a street and read off the street name and the direction. So like in this case, if I did a circle from the top, it would first say, it would vibrate a little and say Howard Street, northeast, and that would help me know what streets meet up where I am.
All right, fantastic. So there's several services that are parallel to what we're doing on Chrome OS and Chrome for Android. And we've had these in place actually for much longer. There's an accessibility framework that's built up of a number of APIs. We'll talk about a few of them. And there are services which users can enable as part of their preferences. So on any Android device, you can pull it out right now. You go to Preferences, Accessibility, and you get to enable things like TalkBack, which is our screen reader, allows the UI to be announced and allows you to navigate by focusing on elements. We have Kickback, which is the haptic feedback, which gives me more of a realistic, real-world experience when I'm interacting with the different elements. And then Soundback, which plays the equivalent of what we called ear cons, audio non-spoken events that tell me when something's happened in my application. Again, Erin kind of mentioned it, but it's a very open platform. It's all open source. But we've made it particularly easy to integrate along many axes. One example is that we ship a voice with the device for doing text-to-speech. And it's perfectly good and functional, but if you want a slightly sexier, sassier voice, one that works in a different language, or one that's just more to your preference, you can go to the marketplace and you can download one of many different ones that are available there, written by some of our application partners. Okay, so these devices, we've talked a little bit about what we have to do. More specifically, if I'm an application developer, to make my application accessible on Android, the first thing, if I just use the standard controls, out of the box, they come with accessibility baked in. If I label those controls by setting their content description appropriately, it will automatically know how to speak the elements when we focus on them. Now, users are going to be focusing on these in maybe a couple different ways. One is if my device has a rollerball or a D-pad, that sort of directional pad you see down there on the screen, allows me to set focus on different elements in my UI. The ones that come out of the box automatically know how to be focused. If I'm building my own custom views, however, I need to make sure that all of these controls are both reachable and respond to the right events, that they can be focused, and that they will raise the appropriate accessibility events. There's some simple APIs. We'll show you a link where to go to look at that at the end of the talk. And please come to our developer sandbox, and we'd love to show you more about that.
So with that, we want to, you know how earlier we mentioned we were going to have demos? We're going to bring up Steve Jacobs to show us some demos of some applications that he's written for Android that are highly accessible. So,
and while he's getting set up, we can take another question if somebody has one about what we've just talked about.
Switch over.
Anyone?
Well, if nobody has any questions.
No, we have maybe
We
one.
do.
No, somebody's escaping. Okay, good. Oh, no, we hear. Okay, good. Yes.
Okay.
So it seems like a lot of people in this room are already in charge of the accessibility for their companies. If you were somebody who just recognizes that everyone should be able to use whatever you write, what would be a good place to start working on accessibility? Or a good example of a very accessible website for all sorts of disabilities?
So a very accessible website. It's a good question. I mean, generally, simpler websites are easier to make accessible. There's, I don't know, Charles, do you have an example? The best example you could think of? Yeah, that's true. With Chromevox, we have a tutorial. It is highly accessible. However, it's not particularly complex. What I would do is I direct you, we've got a tech talk tomorrow on building accessible applications with HTML5, where we'll actually walk you through everything you need to do to build dynamic accessible applications. They've got a rich application that they'll walk you through. Cool, thanks. Steve.
Thank you, Brad. Thank you, Erin. Thanks to the audience. The question was just asked about an example of an accessible website. Building a business case is important if you want to integrate accessibility within your company. I'm a businessman. I'm in business to make money, and I'm in business for applications to be accessible, usable, and useful by as many people around the world as possible. So for right now, let's not think about people with disabilities, of which there are 826 million worldwide. Let's just concentrate on people like myself, 65 years of age and over, 519 million, and 1.2 billion people who never learn to read. How are they going to access your apps and go shopping and spend their money? That's where accessibility is powerful. I'm going to show you two examples of apps that we recently developed.
Android.
The first is Khan Academy. I need to turn on TalkBack's
Typing.
virtual
Navigating.
D-pad. Khan Academy is a not-for-profit educational organization whose mission is to evolutionize education as we know it in the country, actually around the world. They have about 10 million students taking their tutorials. They've developed 2,200 short video tutorials on subjects such as history, math, science, and so on. Using the built-in accessibility that's already in Android, if I swipe down the D-pad,
Math. Science. Humanity. Science. Math.
if I want math and I hear it, I don't have to be able to read, I just tap it.
KH Android. Arithmetic, the most basic of the math playlists.
Ah,
Start here.
arithmetic.
Developmental math work.
Developmental math.
Arithmetic, the most basic of the
Arithmetic.
math playlists. Start here if you KH Android Basic Edition 271,325
Let's go into Edition 2.
views, adding 2-digit numbers. YouTube image button.
We will
In the
now
last
see.
video, we got some practice adding what we could consider
phone off,
smaller
screen
numbers.
off.
For example, if we added
6:03
3
p.m. ringers, phone,
plus
YouTube.
2, we
Hidden.
could imagine that if
Typing.
maybe I had 3 lemons, 1, 2, 3, and if I were to add to those 3 lemons, maybe 2 limes.
Navigating.
Is it lime or limes? Let's just, well,
Hidden.
two green lemons or two more tart pieces
We
of
can
fruit.
turn
how
captions
much
off.
tart, sour fruit do I have now?
Alert
well,
captions.
we learned in the last
YouTube.
video we have
Or turn them
1,
on.
2, 3,
We
4,
can pause the video.
5 pieces.
We can move the video ahead.
Let's start at 0, and
And
0
I'm
means
going pretty
nothing.
quick here.
If I have 0 lemons,
Orientation.
If I have 0 lemons, it means I have no lemons. So 0, 1,
Typing.
2, 3, 4, 5,
Navigating.
6, 7, 8, 9, 10,
Back.
11. Let's go
Back.
pretty high. 12,
Okay.
that way I can reuse.
That's
KH,
one
KH,
example.
KH Android.
And I wanted to thank Casey Burkhart. Google had a Google I/O, an accessibility Google I/O contest where people submitted code. And Casey Burkhart, you're in the audience. Hold your hand up. Thank you. You submitted code that our developers were able to use to develop this application. Sharing code is part of the DNA of Android and the Google culture. It is very, very helpful. It reduces costs significantly, and when we work together as a community, it's a very good thing from a business standpoint.
Launcher.
The second app
Clicked. Alert.
I'm
Google
going to
Reader.
demonstrate.
Alert, please wait. Google.
We've all seen ebook readers. There has been a lot of talk lately about ebook readers that can't read out loud or that won't. This is Cool Reader. We've simply taken the open source code and our developers added speech and highlighting and extra controls to the app, all because it's open source and it's a community of sharing. This will give you some idea of the controls that you have just having a touch screen. Let's
For a whole day.
read backwards.
For a whole day. Indeed, my only wonder was that he had not already been mixed up in. I was not surprised.
Or we can read one word at a time.
Word. Byland. Kings. Sentence.
Or go back to, okay, we're
Word.
back to the sentence.
Sentence.
Let's go into night mode. You can see it better. We'll go back into day mode. We can turn a page, or turn it back, or increase the size of the font. We can do that again. Maybe again. So people who are not able to read, who are learning to read, learning English as a second language, young students who want to be able to access resources like this, having an interface that is accessible can enable them to do that. It is very, very powerful. So expand your thinking about accessibility beyond disabilities if you're narrowly focused on disabilities. A couple of other features and then I'll stop. We can go to the table of contents.
Alert table of contents. Google Reader.
And turn some pages. I can dim the screen if I want to. I can brighten the screen. There are 20 commands built into the touch screen in 9 little areas. We actually make templates that we can put over as screensavers that enable the students who are blind that we work with to fully control this application, fully control Chondroid and many of the other applications we develop. Thank you.
Thanks, Steve.
You're welcome.
Let me switch back over.
All right, Steve, that's awesome. That's wonderful. So I want to just kind of reiterate a couple of the points about Steve's demo. On Cool Reader, they were using gestures, notice, that didn't require the user to look at the screen. User, no matter where they started from in their gestures, they always kind of knew how it would make sense. Some of them were relative to different parts of the screen, but I didn't need to see the screen. And then they provided a lot of verbal feedback to the user. So the user, again, could know what was going on without seeing what was on the screen. Chondroid is a fantastic example of rethinking how do I make it possible for more users to use my application by adding other modes of accessibility. And we're really proud that they were able to reuse some of the code from the developer challenge we had.
So let's talk a little bit about making your products accessible for people who are deaf or hard of hearing. As Dr. I. King Jordan said, deaf people can do anything but hear. And by the way, I. King Jordan was the first deaf president of Gallaudet University, which was the first university for deaf and hard of hearing students. Their entire curriculum is in ASL. So mobile devices and deaf communities, mobile devices were rapidly adopted by the deaf community. I mean, when you think about it, deaf people do more than just, we do more with our cell phones than just talk on them, right? I don't know, increasingly use my cell phone less and less for phone calls and more for other text-based things like text chatting and SMS, and now for things like video chatting and watching videos, right? So watching videos with captions goes well with that. We have Jae-Hong Chong here from the University of Washington to show us this great application that they've built to customize, so you can go ahead and plug in.
Yeah. Thanks for introducing.
Wait, hold on. Some of the great technologies that they've built to help make a great video chat experience for deaf users.
It's my great honor to present our work here. Thank you, inviting Google. Yep, so.
There we go.
Yeah.
I'll switch over.
Yeah. Okay. Just show them after present the slide.
Yes. Oh, right, we're still on
Yeah.
slides, sorry.
Yeah, that's fine.
There we go. It's over here.
Yeah, thank you. Basically, I'm a PhD student at UW to work on mobile SL project. It was started about 6 years ago, and then we conducted field study last year, like this picture, using our old platform. So last year, we decided to move to Android to give the same access to Android world. So the reason is that basically there are the system like VRS, video relay service, but it requires high-speed internet service or broadband access. So it means they cannot use that system on the go. So our goal is to provide the same access wherever they are. So we built the video chat for sign language and then working on the cellular network as well as the Wi-Fi. So the reason to choose the cellular network is that we can give that access everywhere. And then, so we optimize something to enable the technology. So we investigate to speed up the encoder to enable to provide video call, as well as the providing low bit rate to be transmitted over the network. So I brought some video here. So our target bit rate is 30 kilobits per second. On the left top, there's the original video. The first of all, we devoted to detect the skin area, and then categorized to some blocks to be encoded with a higher bit rate. So finally, at the bottom, there's two different videos. The right side, it used that information to encode to be better quality. It means the rest of the area will be degraded to meet the same amount of bit. And then that bit rate can be easily transmitted over current cellular network.
So were you able to get the demo to work, or do you want to show the video?
Short video.
Okay.
So actually, as I said before, we decided to move to Android world. So we built the system from last year, and then we had a working system here, but because of network issue, it is not working well perfectly. So I want to show that demo using the pre-recorded video. I took that video yesterday night with the 3G cellular network. So seems to be better, but at here it's not working. So please come by our Sandbox booth. We're going to show more information. Thank you.
Great. Thanks, Jae-hong.
Yep.
You can do this. So to summarize, there are some key things that you can do to make your applications accessible. One is to just make sure you understand your users and the use cases under which they'll be using your products. Focus on making products that enable independence and have multiple ways of interacting so that you don't end up relying on one method, like using a mouse, that you have redundant methods, like using a keyboard. Make sure that you provide good feedback in your applications so that your users know where they are at all times. And also think of your entire end-to-end experience from the moment they log in or even browse your product, like to browse your website to learn about your product, to the point where they're setting it up, using the settings, and looking up documentation.
That's right. So just to leave you with a couple points from the talk. Our standard toolkits come with great accessibility built in. Use them. There's a couple things that we want to make sure. The biggest thing you can do is to make sure that your application can be used by the keyboard alone, if it's a web app, or can be focused and used by a trackpad or a rollerball if it's a mobile application. I want to make sure that I'm handling tab and focus events properly, whether I'm in Android or on the web. And then test it in the type of accessibility technology that you want to target. So download Chromevox and try your application out, or use the TalkBack on the Android platform.
So there's a number of ways where you can learn more about accessibility while you're here at I/O. The first one was unfortunately a session that was earlier today, which you're going to have to catch on YouTube, but it was great. It was a session on using Android and making your Android app accessible. Tomorrow at 12:30, we have a session on YouTube, captioning API and speech recognition in WebVTT. And then from 3 to 4 tomorrow afternoon, we have a presentation on making accessible web apps using HTML5. Then all day, today and tomorrow, we have a developer sandbox out here on the second floor. It's one of the yellow booths for those of you who are photon dependent. There's 8 different stations there, and you can get a better sense of all these applications and use them yourselves. The demos will be there. And then we also have office hours right now, actually, started at 3 o'clock and going until 6:30 today. And then tomorrow from 3 to 5. And those are, again, on the second floor. If you walk around, there's 3 little nooks, and we're in the last one outside the room at the end.
Great. Okay. So to give us feedback, we would love to get your input on how this talk went. There's a QR code at the top, or you can just type in the feedback link. The links for the other things we referenced during the talk, including how to download Chromevox and Chromeviz, and Chrome Shades, are there at the second link. Thanks, everybody. Please come up to the mics if you have other questions.